Unit 4 is all about lines. So we're going to be talking about horizontal, vertical, lines with different slopes. We're going to be talking about how to write the equation of a line in different forms, such as point slope, standard, and slope intercept. We're going to be talking about how to graph a line using those forms as well. And then we're going to go into a little bit about parallel and perpendicular lines, which will lead us into Unit 5, which is all about what happens when we have two lines and they may or may not be crossing. So today we're really going to focus on what is an intercept, how do we find them, and even further, how do we use that to potentially graph a linear function. So let's start by defining what a linear function is. We just spent an entire unit talking about functions, so thinking about the vertical line test, and thinking about a line, a linear function is a non-vertical line. So a linear function is a line, some people like to call this a diagonal line, but it's a line or a horizontal line. Those are linear functions. So these are linear functions. They make us smile. They pass the vertical line test, as opposed to a vertical line. A vertical line does not pass the vertical line test because if I drew a vertical line right here, it's crossing everywhere. So this is still a line, obviously, but it's not a function. So not a linear function if it's a vertical line. Still linear, however. Linear is just a real fancy way to say line. The word line, in fact, is in the word linear. A linear equation is in standard form. So this is one of the three forms we're going to focus on in this unit. It's in standard form when it is of the form ax plus by equals c, where a, and we're going to talk about this more in a future section, but a is a non-fraction positive number, and b and c are both not equal to 0. So we're going to talk a little bit more about the technical ways that this needs to be written, but what you should know for today is that ax plus by equals c is called standard form. The big focus of today is about intercepts. So I'm going to put a big box. This is probably the most important thing that we're going to talk about today, the X and Y intercept. So an intercept, just like in sports where something is crossing, right? In football, when there's an interception, someone cuts in and takes the ball or catches the ball that was going to someone else. That is an interception. So in math, when we're talking about an intercept, we're talking about where the point crosses one of the axes, the x-axis or the y-axis. So the y-intercept is the y-coordinate of the point where the graph touches the y-axis. So the y-intercept is going to always happen when x is equal to 0. The y-intercept will be that number in the second spot of that ordered pair. The x-intercept is the x-coordinate of the point where the graph touches the x-axis. So for the x-intercept, the value that we're looking for, the x-intercept is the first part of the ordered pair, and 0 is the second part of the ordered pair. So big things to notice. How are we finding intercepts then? Well, to find the y-intercept, you plug in 0 for x. To find the x-intercept, you plug in 0 for y. If you're looking at a graph, to identify the y-intercept, you look at the point that's on the y-axis, and to identify the x-intercept, you look at the point that's on the x-axis. So for number 1, we are given a graph. To find the y-intercept, we're going to look at the point that's touching the y-axis. So the y-intercept, which you should always write as an ordered pair, x is 0, y is -1. Similarly, the x-intercept is the point that's crossing the x-axis. So the x-intercept is the point 2, 0. Go ahead and pause the video and try and do number 3. From the graph, identify the x and y-intercept. Okay, the y-intercept is crossing the y-axis at 3, so the y-intercept is the point 0, 3. The x-intercept is the point that's touching the x-axis, which is -2, 0. So when you're looking at a graph, you're just looking where are the points crossing the x and the y axis. When you are looking at an equation, like in number 2 and number 4, what you're going to do is actually plug in 0 for one value to find the other intercept. So for example, let's find the x-intercept first on number 2. To do that, we're going to plug in 0 for y. If I plug in 0 for y, I get 5x minus 2 times 0, which is just 0. 5x minus 0 equals 10, which means that x is going to be 2. So the x-intercept is the point 2, 0. When I plugged in 0 for y, I got 2 for x. Similarly, the y-intercept is what we're going to get when we plug in 0 for x. So 5 times 0 is 0, so negative 2y equals 10, which means that y is going to be negative 5. So the y-intercept is the point 0, negative 5. Go ahead and pause the video and see if you can work through number 4 in the same way. So look at what I did in blue to find the x-intercept. Look at what I did in purple to find the y-intercept. So the x-intercept is what I get when y is equal to 0. That's going to give me negative 3x plus 5 times 0, which is just 0, equals 30. So remember, I'm just using this equation, and over here I was just using this equation, plugging in 0 for y to find the x-intercept, and then plugging in 0 for x to find the y-intercept. So here, this is going to give me that x is equal to negative 10. So the x-intercept, x is negative 10 when y is 0. The y-intercept I get when x is equal to 0. So if x is equal to 0, negative 3x in the red equation is 0. So I have 5y equals 30. If I divide both sides by 5, y equals 6. So when x is 0, y is 6. That is my y-intercept. Now let's look at how we can use these intercepts to graph a line. Graphing using intercepts. The very first thing you're going to do is exactly what we just did. We're going to find the x-intercept and the y-intercept. So we're going to find the number, 0, that's our x-intercept. And then we're going to find 0, the number, that's our y-intercept. Once we have found those 2 points, we're going to plot them. Then we're going to connect the dots and make sure that we have arrows on the ends of our line. All we need are 2 points to make a line, so these 2 points are going to come from the x and the y-intercepts. So why don't you go ahead and pause the video, find the x and y-intercepts for 5 through 8. You can write them on those lines, and then unpause and see how you're doing. All right, the x-intercept, when y is 0, we get 3x equals 12. That means that x is equal to 4. So the x-intercept is the point 4, 0. I'm actually going to just keep going and find the x-intercept on each problem. So here, to find the x-intercept, I'm plugging in 0 for y. So 0 equals negative x plus 4. If I add x to both sides, x equals 4 is going to be my intercept again, 4, 0. Here, there is no x value. Y is always equal to negative 2. So if there is never an x value, there is no x-intercept. So what you will do is write none. It's not that it's undefined, it's not that it's 0, it's that it just doesn't exist. Here, x is always 2. That means the x-intercept happens when x is 2 and y is 0. Now let's go back and find all the y-intercepts. So now we're saying what happens when x is equal to 0. Well, here we would have negative 4y equals 12, which would mean that y is negative 3. So the y-intercept would be the point 0, negative 3. Here, we would have y equals 4, or y equals 0 plus 4. So 0, 4 would be our y-intercept. Here, y is always negative 2, so that means that our y-intercept happens at 0, negative 2. Here, x is always 2, so there is no y-intercept. Now, we're going to go back and plot each of those points and connect them. So 4, 0, 4 to the right, 0 up or down, and 0, negative 3. Then we're going to connect those to the best of our ability with a straight line. In Go Formative, you're actually going to have the ability to do that using a straight line feature. Make sure you have arrows on the ends of your line. For number 6, 0, 4 is the y-intercept, 4, 0 is the x-intercept. We're going to connect those and draw arrows going through on the ends. Number 7, the y-intercept is negative 2. There is no x-intercept. So y equals negative 2, if you think about that, that is just a horizontal line. It looks like this. So that's why there is no x-intercept, because y is always equal to -2. So anytime you only see one variable, y equals or x equals, y equals a number is always going to be a horizontal line. X equals a number is always going to be a vertical line. So if you think about number 8, here is where x equals 2. This is going to be a vertical line because everywhere along this line, x is equal to 2. Now let's tie this together in a word problem so we can kind of understand the context around why this might be helpful or useful. A school sells pens for $2 and notebooks for $3. The equation 2x plus 3y equals 60 describes the number of pens, x, and notebooks, y, that you can buy for $60. Part 1 says to graph the function. Part B says to find and interpret the intercepts. We're actually going to do that in the reverse order. So let's find and interpret the intercepts first. So I want to mark off that the x is talking about pens and the y is talking about notebooks. So let's find the x-intercept first. Remember, that's what we get when y is equal to 0. So that would give us that 2x is equal to 60, or x is equal to 30. Now think about that, what that means. That means if we spent all $60 on only pens, we would buy 30 pens. So if we spent all $60 on only pens, we could buy 30 pens. Now let's look at the y-intercept. The y-intercept is what we get when x is equal to 0. That would be that 2 times 0 or 0, 3y equals 60, which means that y is equal to 20. So to interpret that, if we spent all $60 on notebooks, we would be able to buy 20 notebooks. So we have found our intercepts, and we have described what they mean in context. So now we're going to graph them. So make sure you label your axes. X is going to be the number of pens. I'm going to try and fit that down here. Pens. Y is going to be the number of notebooks. I'm going to go by 5s. So I'm going to mark off every 10. Like so. So the y-intercept is 0, 20. I'm going to put a point right here. The x-intercept, I'm still going to go by 10. So 10, 20. Notice there's no negative numbers here. It wouldn't make sense for us to talk about a negative number of pens or notebooks. So here's the x-intercept. When we connect this, we are not going to put arrows on the ends because, again, it doesn't make sense to be talking about negative number of pens or notebooks. So every single ordered pair that would be on this line is an example of how we could spend that $30 if we were spending the full $30 on pens and notebooks. So key reminders from this section. Intercepts are what we find when we plug in 0 for the opposite variable, or intercepts are points that cross the x and y axis. The x-intercept is the point that crosses the x-axis, which means that y is equal to 0. The y-intercept is the point that crosses the y-axis, which means that x is equal to 0. So to find these, we're just going to plug in 0 for the other variable to find that intercept, and we're going to write the intercepts as ordered pairs. If we are graphing using intercepts, we're going to find the intercepts in the exact same way, plot them, and then connect the points using arrows on the ends. The only time you're not going to use arrows on the ends is if we are in a word problem with something that doesn't make sense to talk about negative values, or if you're given a specified domain like you were in Unit 3, which is probably not going to happen for this particular unit. Looking forward to practicing more with intercepts in class. Thanks for listening.